All right, so maybe you thought about why there are millions of these pear trees in my backyard. And some of those things are the fact that things eat it, right? And there's also natural disasters that can happen where maybe the seeds were not exposed to enough water, so then it went through a drought and it died. So those things are actually called limiting factors, okay? So limiting factors. Say that out loud.
Limiting factors.
Awesome. And so limiting factors, there's different kinds. There's density dependent ones and there's density independent ones. And we are going to be going over those a little bit later as far as like what the definition is and then some examples. But before we do that, what we need to go over are some simple things about population growth, okay? So if we look over here,
A whiteboard fell.
here's our outdoor classroom, right? Times are tough now. There's different kinds of population growths. There's population growth that looks like a J-shaped curve. This is on the y-axis is the number, and then on the x-axis is time. So the higher or faster this goes up over time, that's exponential growth. I'm just going to put an E for short to make it simple. The other kind of growth also has the y-axis labeled, because we always label our axes, is number, x-axis is time, and in this situation, we actually see what they call an S-shaped curve, okay? And so with this is actually called logistic. And logistic growth actually kind of takes into account those pressures that don't allow this to continue up, okay? So some of those pressures are those factors that would make this population not exceed this. It would actually just kind of flutter around there, okay? This population here, this is exponential growth. It's increasing by a constant percentage over a period of time. Over here, logistic growth takes into account these factors, okay? And we'll stop right there.